All right, we're going to be working on stoichiometry test review problems, questions 3 through 6. We're in period 4. Would you like to say hello to everybody else?
Hello.
Hello. So again, when you do these problems, you want to have a periodic table nearby. Have your reference chart, your most valuable player of chemistry chart, and here's our questions. We've just finished 1 through 2, so let's work on question 3 now. So let me zoom in. So question number 3, how many grams of oxygen are required to react completely with 8 grams of hydrogen? So first off, I'm going to get my table set up here. Since this is blank, I haven't done anything, modified it. Let me see. Whatever we're given, I usually put over here. We are given grams of hydrogen. So I'm going to call this side. Now, is it H or H2?
H2.
It's H2 because it's hydrogen gas. So grams of it, we're given grams of H2. So we're started here, and we are given 8 grams of hydrogen. So 8 grams H2. We're given that already. And the problem is asking us to go to how many grams of oxygen. All right, this is a gram-gram problem, just like we've practiced mass problem on our worksheets. We're going to come over here. I'm going to call this O2. So molecule B is going to be O2. And we're looking for blank grams of O2. We're going to need to convert to moles. Then we're going to do the mole-mole ratio. And then we're going to be converting back to gram. We've got a 3-step conversion, just like we've been practicing. So to begin with, let's see. I'm going to better get some blank paper. It'll be easier to see. Then, whoops. So we always start with what we're given. 8 grams of H2. Can you see that all right?
Yeah.
Okay. 8 grams. Don't get sloppy. It's not 8 grams of H. It's H2. And now the next step is, since we're down here, we need to convert to moles by the molar mass, the moles over gram. So we want 1 mole of H2 is how many grams? Well, if you're not sure, hydrogen is 1, and we have 2 hydrogens. So what would the molar mass be? 2 grams of H2. So at this point, we've done our first conversion. We've converted to moles. Now we need to do our molar mass. We're going to go, we need moles of oxygen, which is B, on how we're setting this up, over moles of hydrogen. So now we look to the balanced equation. So let me scoot this down so we can see the balanced equation. Moles of oxygen. How many moles of oxygen do we have in the balanced equation?
1.
You guys sure? Yeah, okay, you sound okay. 1 mole of O2, because that's what we want to convert to, oxygen. And we're coming from, how many moles of hydrogen is there in this balanced equation? 2. So we have 2 moles of H2. So now what we have done, we have now jumped across from hydrogen over to moles of oxygen. Don't you love stoichiometry, how you can do that, a balanced equation? Okay, maybe you don't. I love it, but I mean, it's fun. I mean, okay. Oh, so now we're over here. The question, we want to get to grams of oxygen. That's right, that's what we're looking for, right? And we know we want grams of oxygen because that's what the problem said. If you use the roadmap here, we're coming to here. So now to go from moles to mass, on our detailed side, we're going to be multiplying by grams over mole. So 1 mole of O2 is how many grams?
16.
Well, let's see. Oxygen is how much?
16.
And since an oxygen molecule is O2, what is the mass?
32.
It'll be 32. You got to be careful there. So 1 mole of O2 is 32 grams of O2. Oh, grams. Oop. So now let's, I think we got this set up. Grams of hydrogen should cancel there. Moles of hydrogen should cancel there. Moles of oxygen should cancel there. And now, well, let's cross this off. How many times does 2 go into 8? Come on, you can participate. You don't have to be afraid. How many times does 2 go into 8?
4.
4, okay. And we have another 2 we can cancel out. So, well, you can either reduce 4 again, or you can reduce this one. I'm going to, what do you want to do?
Reduce 32.
Okay, somebody said reduce 32. I don't care. You can do either one. So I'm going to, 2 goes in there once. 2 goes in here how many times?
16.
16. So now, for our problem, the multiplication is going to be 4 times 1 times 1 times 16. So that's just 4 times 16. Divided by 1 times 1 times 1. So we don't need to worry about that. What is 16 times 4?
64.
I'm hearing 64. You guys agree with that?
Yeah.
Okay. So 64, and it's grams of O2. And is that what we were looking for? Okay. Any questions on that before we go to number 3? Actually, number 4. Say again? Now, somebody just said you may have done something different and you got the right answer. If there can be a different way to set it up. Maybe did you cancel different than I did, or did you?
48. I put the 8 grams for the H2. What was given?
Okay. You put 8 grams for what was given. That was what was given, because what we did was when we got this 4 right here, that was when we reduced the 2 and there. So it wasn't 48. It was 4.
Oh.
Okay, there we go. All right, number 4. Let me rotate this. Make sure we can see the balanced equation. How many molecules or atoms of hydrogen are required to react completely with 30 molecules of oxygen? So now we're going hydrogen to oxygen. So we're going to need, it's going to be going from one chemical to another. So we will be making this mole-mole boundary. And how many molecules or atoms of hydrogen? Well, let's see. We're going to do molecules because hydrogen's a gas. So how many molecules? So we're going to start with, we're looking now for hydrogen. I'm going to erase this. This was my given in the other problem. And we're looking for blank molecules of H2. This is still labeled H2 for my previous problem. And we're given 30 molecules of oxygen. So I'm going to come over here now. This is going to be still my oxygen side, but this time oxygen is given, and it's 30 molecules of O2. Now, setting this one up, if we look at our balanced equation, we've got 30 molecules of oxygen, and we're going to hydrogen. If we've got a mole ratio of 1 to 2. Now, here's a shortcut you might be able to do if you're there. For every mole of oxygen, we're going to have 2 moles of hydrogen. So if we have 30 molecules of this, we're going to have twice the molecules of hydrogen, which would be what? 60. Okay, so now some of you may be going, what? I can't do that. I don't get what you're doing. Okay, good. We'll do the story. We'll do the problem. But when we're going from molecules to molecules, it's going to be in the proportion of here. So now we'll do the math to show you how you got that. So we are given, in this problem, 30 molecules of O2. Did I get that set up right? I use molec just because it's shorter. And then let's see. So we're starting over here. We need to convert to moles by dividing by Avogadro's number. So there is 6.02 times 10 to the 23 molecules. Excuse me, I'll put that under here. Molecules of O2 in 1 mole of O2. So at this point, we've canceled off molecules of O2 with molecules of O2. And we're here, now we need to do our molar ratio. So now we're going this way. We need moles of what we're going to, moles of hydrogen over moles of oxygen. In our balanced equation, how many moles of hydrogen do we have? Come on, everybody, help me out here. How many moles of hydrogen in that balanced equation? 2. 2 moles hydrogen in 1 mole of O2. Again, we're going from oxygen to hydrogen, so what we're going to needs to be on the top, moles of hydrogen over moles of oxygen. So now we've converted. Now we've got moles of hydrogen, and we just need to go to particles, because that's what we're looking for. Actually, in this case, molecules of H2, by multiplying by Avogadro's number. Oh, moles of O2 cancel out. So now, 1 mole of H2 is how many molecules of H2? 1 mole of H2, how many molecules will we have? You look at your chart right here. What are we going to? We're going to particles. What's the magic number for particles? 6.02 times 10 to the 23 molecules of H2. Now, moles of H2 cancel. And at this point, we can cross off our numbers. Let's get the big monster done first. Let's get Avogadro's number canceled down there. And now, are we at 30 times 2? Which is what? Equals 60, and it's molecules. Now, when I started the problem, I was up here looking at mole ratios. If you can't quite get that, then just set up the equation like we've been practicing. And let's do number 5 now. Oh, any questions on there before I go on to number 5? Now, first off, number 5, I had you cross off the first part. So we've got 1 mole of oxygen, and we want to know how many grams of water. So again, we're given oxygen, we're going to water. So we are going to be doing a mole-mole ratio in the middle of our conversion. So I'm going to put, in this case, I've already got oxygen over here, so I'll keep oxygen on this side since I've already got it written. But now we're going to water. So I'm going to make this side of the equation, H2O, this is now be water. And we're given moles of oxygen, so we're starting right here. We have 1 mole of O2. No problem, sorry about that. 1 mole of O2. This is the given. This is where we're starting in this. And we're going to grams of water. So we've got to do the mole-mole ratio, and then we're going to be coming down here to grams. So we've got a 2-step conversion process. We'll end up over here with grams of water. So let's get our molar ratio set up. We need, since we're going this way, we need moles of H2O over moles of O2. Oh, I guess I better start with what's given. 1 mole of O2. That's what's given. And how many moles of water do we have in the balanced equation?
2.
We have 2 moles of H2O for every, and we started, how many moles of water do we have? Excuse me, how many moles of oxygen?
1.
So now moles of oxygen cancel. We've come from over here to here. Now we just need to multiply by grams over moles, the molar mass of water. So let's see, 1 mole of water. What's the mass of 1 mole of water? Yeah, and if you're not sure, we got H2O. Oxygen is 16 plus 2 hydrogen, so it's 16 plus 2 is 18 grams of H2O. Okay. And those cancel, and we've got, is this 2 times 18? That's a reduce. So what's 2 times 18? 36?
Yep.
Does that sound about right? 36 grams of H2O are what we ended up with. Okay, I want to end with number 6 here. Number 6, we're given the volume of oxygen. How many moles of water? Okay, so given liters of oxygen. So on this chart here, I still have O2 listed here. I'm given liters of oxygen. And in this case, we're given 11.2 liters of O2. This is my O2 side from before. And we're looking for moles of water. So we want to come over here. So now, in this problem, we want to go to moles of water. So we've got a 2-step conversion. We're going to moles of oxygen, and then we'll do our molar ratio. That'll convert it into moles of water for us. So that's our roadmap. Volume to moles, molar ratio over here. So what's given in the problem? Because you start every conversion with Hello? Are you awake out there?
11.2 liters of oxygen.
Now, it's liters of oxygen. Remember, in our balanced equation, it's O2, so you need to set that up correctly. Since we're not converting to grams, it's not going to really affect us yet. So now we need to go from volume to moles, and to do that, we divide by 22.4. So 22.4 liters of O2 is 1 mole of O2. Liters of oxygen can cancel, and we are now at moles of oxygen. And now we do our molar ratio. Since we're going to moles of water, we need that on the top. How many moles of water? Got 2 moles of water. Wait, do you guys see that? I have one person answering. Are you guys seeing there's 2 moles of water up there?
Yeah.
So 2 moles of H2O. And we're coming from oxygen. How many moles of oxygen in the balanced equation? 1 mole of O2. This cancels. And we can cancel these, right? We do that. So 2 goes into 2 once. How many times does it go into 22.4? 11.2. That'll cancel that out. Oh, cool. 11.2 cancels with 11.2. Don't you love math? Don't you love math? Go back and thank your teacher, your 3rd or 2nd or 4th grade teacher taught you how to cancel. This becomes 1, that becomes 1. What's 1 times 1 times 1? 1. Divided by 1 times 1? 1. So the answer is 1 mole of H2O. Yay! Okay? All right, we'll stop it here.